All right, so in our example below, we have something similar to some of our homework questions, so we're going to try this out. Nonlinear divisor, I cannot use synthetic division. I must use the long division form. We call this polynomial division. So dividend and divisor, we'll just set those up with our division here. And as I'm going here, I'm just going to stick in 0 placeholders wherever needed. So the big thing is I just want to align things with common variable and exponent values. I can't align something like an x cubed with an x squared because I can't subtract those. That would be a problem. So if you need to, put in a 0 placeholder along the way so that things are aligned. So our first step is we're just looking at x squared, x squared and x to the 4. So x to the 4 divided by x squared. That's going to be x squared. And then we will multiply. So x to the 4, x squared times 2. That gives me positive 2x squared. I'm aligning it with the other x squared. If you want to, you can put in a 0x cubed here so that you know there are 0 of them. And we subtract. Okay, so x to the 4 minus x to the 4, 0. Negative x cubed minus 0 is just negative x cubed, so that will stay. Negative x squared minus 2x squared, negative 3x squared. Drop the next term. Okay, so a lot of times in these ones we're dealing with sort of like 3 terms at once in our expressions here. Okay, now we're doing x squared into negative x cubed. If I'm not sure what that is, I'm going to write it over here. Of course, I'll have a negative 1 left, and then x cubed divided by x squared, I'll be left with just 1x, so it should be negative x. That's what we'll put up here. So negative x, multiply. Okay, so we did our divide. We're going to follow divide, multiply, subtract, and repeat. So I get negative x cubed here. Negative x times positive 2, that's negative 2x. I need a placeholder here now. So plus 0x squared, and we will subtract. So x cubes cancel. Negative 3x squared minus 0, it's just still negative 3x squared. And 2x minus negative 2x. Minus a negative, that's like plus, right? So plus 4x, drop your last term. Plus 1. Okay, last thing that we're going to check, can x squared go into negative 3x squared? Can I divide those? Is this possible? If so, what is it equal to? Clayton?
Negative 3.
Yeah, the x squareds just cancel. I'll be left with negative 3. Okay, so that answer goes up here. And we're going to repeat this process one last time. We're just going to multiply that negative 3 in. So negative 3 times x squared, negative 3x squared. Negative 3 times positive 2 is negative 6. I've got a 0x placeholder that I need to slide in there. And then you're just going to subtract one last time. So 4x minus 0 is 4x. And 1 minus negative 6, that should be positive 7. Can I divide x squared into 4x? I mean, I kind of can, but then I would start getting fractions and stuff like that. So then that gets to the point where we're like trying to work with like fractions and decimals and stuff. So it can't go fully into 4x. So I would just consider that whole thing to actually be my remainder. Okay, don't be surprised if this happens when you have a nonlinear divisor. That's going to happen. Okay? Can I clarify anything here? Yes, Serena.
When you say nonlinear, what does that even mean?
So linear means degree 1. This is degree 2. That's a quadratic divisor. Has an exponent of 2 on the x rather than an exponent of 1 on the x. So this versus this, right? This is linear, this is a line, it's degree 1. This is degree 2, it's a quadratic. I can also divide by anything higher than that too as well, right? But if I have something that's greater than degree 1, then I will probably get something like this in the remainder. All right. Any other questions on this one? Okay. So I want you guys to decide, we're sort of recapping from last week, and we're practicing some of the things that we talked about in the homework as well. So you and the person next to you are going to decide, can I use synthetic division, or must I use polynomial division? And then you're going to apply the division, so do the division, and then you're going to express your answers in quotient form. Okay, so I'm going to give you guys a couple minutes to do both of these and decide which type of division needs to be used here. What did you discuss about which type of division needs to be used for each here? What would I use for A? What would I use for B? Zach?
I think A is the synthetic.
Yep. And does that mean B is the other one?
Yeah.
Okay, so we'll use polynomial division here. How did you know that, Zach?
I'm a good guesser.
50-50 chance? Sarwa?
Because it's the divisor is linear.
Okay, so this one, the divisor is degree 1. There's an exponent of 1 on the x. This one, the divisor is x squared. So we have to use, well, we don't have to use synthetic, but synthetic is nice and quick. So I personally prefer to use synthetic where possible. So I'm going to put a 3 out here. That comes from the x minus 3. And then I'm just going to write the coefficients. This is a good recap of what we did last week. We're going to write the coefficients. There's no missing terms in the dividend, so I can just write them all out. And we add this column and multiply over here. So someone refresh my memory. How do we now go through this process now that we have it set up? Nick? Okay, first step, drop that. Okay, so 3 times 1, write the answer in the next column. So it'll be 3. And then add, so we get 5. 3 times 5, 15. Okay, add them, we get 6. Multiply one more time. Okay, and then we add, and that's 2. What does this give me? This just gave me a bunch of random numbers. Zach, how do I use these?
It gives you the remainder, and then the number. I don't remember what we used for it, but under the 2 is the remainder.
Mm-hmm.
The 6 is the hashtag, whatever you use that for. I don't remember.
This is also the number sign. You guys know that, right? Maybe I should start using C from now on for constant. Yeah, so number or hashtag.
And then x is 5, and then x squared.
Okay, so this gives me a quotient of 1x squared, so we just put x squared, plus 5x, plus 6, and the remainder is 2. So if I want to now express this in quotient form, I'm going to say that our original question You okay there, Sarwa?
No, Clayton's really distracting me.
Clayton.
She flew in the last agenda.
I did see that. I saw something out of the corner of my eye. Okay. Keaton's yesterday's news. Now it's Sarwa.
Clayton's not worth the energy.
Ah, I see.
You're tired of losing?
That's your value. Not worth the energy.
All right, so there's our quotient form. So this equals the quotient plus the remainder over divisor. Okay, who was able to get B that wants to take us through here? We had to use polynomial division, so I'm just going to set it up quickly before I choose somebody. Serena, do you want to do this one?
Okay, so, the first one I got was like x to the power of 3.
Shh. Okay, so x cubed, that's the result of x to the 5 divided by x squared.
Yeah, and then
Okay.
you just subtract that under, so you get x to the power of 5. And then x to the power of 3 times 1 is x to the power of 3.
Okay, so what I might want to do at this point is just slide these over and put in a 0 placeholder up here. Okay, so I can do that, right? If I just use pencil, I can always just erase and start here. Okay, sorry, Serena, go ahead.
Yeah, so then after that, I got negative x to the power of 3, and then you drop down the x, and then there. And then I did, then it's just negative x.
Okay, so that comes from negative x cubed divided by x squared. Go ahead.
And then you do negative x times 1, so it's just negative x. And then since it's negative and negative, that will become positive 2x on there.
Mm-hmm.
And then you drop down the 1 plus 1, and then that'll be your
Yeah, so I actually can't do x squared into 2x, so that tells me that that must be my remainder then. Okay, so quotient form, who can set up quotient form for us for this one? Clayton?
X to the power of 5 plus x plus 1 over x squared plus 1 equals x cubed minus x plus 2x minus 1 over x squared plus 1.
Good. Thank you. Okay, so still we're doing quotient plus remainder, whatever that remainder is, over divisor.
Well, you keep looking at me, I don't know why.
I don't know, I heard a little whisper. Are you like throwing shade from across the room or something?
Why
Or?
are you looking at me, weirdo?
All right.
Can we work our sizes?
Moving forward.
Give an answer.
You know the answer.
I don't know why you're so opposed to it.
I mean, it's a little hard to teach math outside.
No, like just when we do the worksheet.
Nah. All right, guys, so this is our second theorem. First, we have remainder theorem, and we know that we can use remainder theorem to find the remainder when a polynomial is divided by a linear divisor, so like x minus b or ax minus b. Factor theorem follows immediately from remainder theorem, and factor theorem says, basically, if we use remainder theorem, if we calculate what the remainder would be for a linear divisor, x minus b or ax minus b, and we get out 0, then we know that that divisor is a factor of the polynomial. That is the theorem. So it's basically the same as remainder theorem, but then it says if you get 0 as the remainder, then that binomial, that linear divisor x minus b or ax minus b must be a factor of the polynomial. So what does this mean? Well, basically what this means is actually our question that we took up from example 5, or from 5 from the worksheet, is a good example of this. So I divided x plus 5 into this polynomial. We got a remainder of 0. And what this actually means is that x plus 5 can be used to fully factor this polynomial into a form where it's in perfect factored form like this. Doesn't necessarily mean that this is going to be factorable, but it definitely means that x plus 5 is actually representing a binomial that is an x-intercept of the polynomial itself. So we can use this information now. Some of you guys were asking, okay, so if I have standard form, how do I get into this factored form where I can see the zeros and their orders and all of this? This is the way. We can use factor theorem to help us with this. So let's jump back here. Whoops. There's all my tabs. Okay, so we've got our factor theorem. This one is asking determine, we have two polynomials, determine if x plus 3 and x minus 2 are factors of the polynomial p at x. So we are first going to test the 0 of this binomial, which is negative 3. So I'm going to sub that in for all the x's here. So negative 27, this is 9 times negative 2, plus 33, plus 12. What does this give us? I believe it does give us 0 because this is 50 or 46 or 45, and this is also 45. Okay, so since the remainder is 0, x plus 3 divides evenly into the polynomial. That means x plus 3 is a factor of the polynomial p at x. So I actually know now that this polynomial has an x-intercept of negative 3, crosses the x-axis at negative 3, because that binomial divides evenly without a remainder into the polynomial. Okay? What about p at 2? Let's try this one. We'll see if this one is also a factor or not. Okay, I don't think that we're getting 0 for this one because the 8s will cancel. That will be 0, but then we have negative 22 plus 12, so that's going to give us negative 10. Okay, so it follows that since the remainder is not 0, x minus 2 will not divide evenly, and x minus 2 is not a factor of p at x. So there is no x-intercept at negative 2 on this graph, but there is an x-intercept of negative 3 on this graph. Or sorry, there's no x-intercept of positive 2. I think I said negative 2. Okay, so remainder equals 0. That binomial must be a factor of the polynomial. That's the rule. Okay, so we have some polynomial f at x. It's divided by x minus 2. We get a remainder of 25. And then we're also given information that x plus 3 is a factor of the polynomial. Determine the values of m and n. Okay, so I want to set up some information with our polynomial f at x and the first piece of information that I've been given. So I've been given that when I divide by x minus 2, the remainder is 25. How do I first set up an equation with that information? Let's use remainder theorem. We did a question similar to this at the end of lesson 1. Bella? Okay, so we'll plug x into all the pieces of this equation as 2. And then Bella is saying we will replace f at 2 with 25 because we know that the polynomial evaluated at 2 should give us out 25 because that's the remainder. So using remainder theorem, and then I'm just going to clean this up a little bit by using BEDMAS. 16 minus 3. And I'm actually just going to move everything without a variable to the left-hand side here. So I'm just going to take one more step here. We'll move the 13 over. It will become negative 13, and we will get 12 here. I have a problem. I have one equation right now, and I have 2 unknowns. I can't really solve for those. I could probably try to guess and check here, but I won't know for sure what the answers are. So I have another piece of information here. This is the second piece of information. It says x plus 3 is a factor of f at x. What does this tell me about the remainder when I divide x plus 3 into f at x, if f at x is a factor? Keaton? Okay, so something being a factor means remainder equals 0. So I'm going to actually set up a second equation with this second piece of information here. I'm going to apply like remainder and factor theorem here. How can I set up that second equation with this piece of information now? What would I evaluate if my binomial is x plus 3? What would I sub into the equation for x? Keaton? Okay, so we are going to now plug in f at negative 3. Okay, so same thing that we did before. And what is f at negative 3 equal to? What did the question tell me about the remainder? 0, so I'm going to replace that with 0. And let's just, again, clean this up a little bit. So negative 3 cubed, that's going to give me negative 27 times 2, so negative 54. Plus 9m minus 3n minus 3. Let's move everything without a variable to the other side. Okay, variables will stay on the right, numbers can move to the left. I'm going to get negative 57, and then when I move it over, it will become positive 57. Okay, I have 2 equations and 2 unknowns. Can I solve for the unknowns now? Okay, we're taking it all the way back to grade 9. 2 equations, or actually grade 10, sorry. 2 equations, 2 unknowns. I can solve for these using something called substitution or elimination. Firstly, I like to make my life easier. Anyone else? No? Okay, you can do it the hard way then. But before we do substitution or elimination, I'm noticing that this first equation is all multiples of 2. This equation can remain equivalent as long as I divide every term by the same thing. So I'm just going to divide everything by 2 here. Okay, as long as I can do this to every part of the equation, that's a perfectly acceptable thing to do. So I'm going to get 6 equals 2m plus n. And anyone noticing something that we can do with the second equation here? Okay, they're all multiples of 3. So I just like to make the equation simpler if ever possible. And I get 3m, what is this, 19? Okay, perfect, thank you. Minus n. This is really nice because now I have 2 variables that have the same coefficient, or I guess they have opposite coefficients, but when I have this, I can use elimination pretty easily. I could also use substitution here, but I think elimination is pretty simple. So basically what we do, guys, is just to remind you, this is kind of far back in your memory, but we kind of like stack these on top of each other, and then we decide whether we add to eliminate one of the variables or we subtract to eliminate one of the variables. So the n's are the same here. I've got a negative n and a positive n. Do I add these together to get rid of the n's, or would I subtract these to get rid of the n's? What is going to cause the n's to be 0? Adding or subtracting? Matt? Adding, because one is negative and one is positive. So we're going to add these 2 expressions. These become 0. 19 plus 6 is 25. And 3m plus 2m is 5m. Okay, so I think we can get m pretty easily here. What's m? M must be 5. Divide the 5 out, we'll get an m of 5. How do I find n now? Does anyone remember how we do this with elimination? Coming back to you, Jacob.
We plug the 5 into the n from one of the other equations.
Yeah, so you can choose either equation. We're going to sub it in and find n. So I'm just going to sub it back into the first one there. 2 times 5 plus n. And we're going to get 6 minus 10 equals n. So n must be 4. Sorry, negative 4. Andreas.
Please, you won't get this on the time,
I was just showing you this example for fun, so
Okay, good.
I'm just kidding. It may be on a test, yes, or an assignment.
Say you forgot to like simplify, like you didn't divide out whatever.
Yep.
Would the answer still be right? Like would it be another?
Yeah, so what you would have to do is if you didn't realize, oh, I can divide all this by 2 or I can divide all this by 3, if you're using elimination, you need to get one of the sets of variables the same. So I can either focus on getting the m's the same or the n's. This one might be easier to do the n's because they're lower numbers. So you would have to go through and multiply the blue equation by 2. I would just make them 6 n's. So multiply every term in the blue equation by 2. Multiply every term in the black equation by 3 so that the n's become 6 n's, and then they can eliminate. I can't use elimination unless I have 2 variables that have the same number coefficient. They can be positive and negative, but they need to be the same number. So I would have to go through and I would have to multiply this whole thing by 2, and I'd have to multiply this whole one by 3 so that the n's had coefficients of 6's on them. Amelia? So for substitution, if you had them still in this format, substitution would not be a good method to go because it would be very difficult to get a variable by itself. If you were to isolate and you find that, for instance, you have a single n by itself with a coefficient of 1, substitution is a decent method as well. You're going to isolate for n. So I would do 6 minus 2m, move the 2m to the other side. And then you're going to sub it into the other equation. So where I see an n in the second equation, I would replace it with 6 minus 2m, and then I have all m's in there that I can solve for. So substitution, we need to get a variable by itself in one equation and plug that expression into the other equation to solve. Good question. Okay, we will have some questions where you guys can practice this skill again. But yes, elimination is probably a little far back in your memory.